This will be the last video lecture for this chapter for the slides before we turn to looking at practice problems. We're going to cover taxes and subsidies. So for taxes, there are many examples. I'm sure you're aware of more where we see taxes applied in our day-to-day lives. So for example, in product markets, sales taxes apply. There are vice taxes on things like tobacco and soda. In labor markets, employers have to pay payroll taxes. Employees have to pay income taxes. In capital markets, meaning more like financial markets, you have to pay capital gains tax. This is going to be similar for folks who own property and their property goes up in value. They also have to pay capital gains taxes. And the common goal of these taxes is often primarily to generate government revenue. But it can sometimes also be to deter the consumption of a good or trade of a good. In the case of like vice taxes, where the city or state that's imposing the tax wants people to smoke less, for example. So they might tax cigarettes. In California, we have very high gasoline taxes, and that's to reduce the amount that people are driving by making gas more expensive. We might also see taxes imposed to mitigate externalities, in particular negative externalities. So we'll talk about that more in chapter 17. But essentially, for any good that is associated with a negative externality, governments might impose a tax in order to reduce some of the trade of that good and reduce the negative externality in that way. So let's look graphically at the effect of a tax. In this graph, we're assuming that the tax is placed on suppliers. So we're going to draw this dotted second supply line that shows the supply curve with the tax, right? What that is going to do is increase the price for that good, in this case, tickets for consumers, but producers are going to continue to receive the price as shown on the initial supply curve. So when that tax is imposed, the price goes up for consumers to $9.30. They reduce how much they want to consume from 400,000 to 340,000. And sellers receive the amount that buyers pay minus the tax. And so in this case, they only receive $8.80. So because for them that price effectively falls, they're also reducing their provision of tickets. So quantity supplied of tickets also falls down to 340,000 from 400,000. So we get this dual movement of quantity supplied and quantity demanded, such that the market stays in equilibrium, right? Meaning that quantity supplied equals quantity demanded, but now at a lower value. And it's due to this wedge between the price that buyers pay and the price that sellers receive, right? Because they face two distinct prices, we get this dual movement, right? It's the fact that the prices for buyers are different from that for sellers that we get quantity supplied and quantity demanded falling by the same amount. That difference between the prices is transferred to the government in the form of government revenue. So this area B that had previously gone to consumer surplus, right before the tax, consumer surplus was area A, B, and C. Now B goes to the government as revenue. C is lost as deadweight loss because of the reduction of trades. And A is all that's left that goes to consumers. For producers, they previously got areas D, E, and F. And with the tax, area D is transferred to the government. They lose area E as a result of the reduced trade, right? It's deadweight loss, and they only receive F. So this slide walks us through those effects that we just detailed, right? So taxes, like all the regulations we've talked about previously, price controls, price ceilings and price floors, as well as quotas, distort market outcomes. Right? They generate, in other words, this deadweight loss. They raise the price for consumers and lower the price for producers, meaning that both quantity demanded and quantity supplied fall in response from 400,000 to 340,000. And the reduction of that quantity traded causes there to be deadweight loss in the market, right? Some consumer and producer surplus is not gained because those trades never occur. The wedge between the prices, right? So the higher price that consumers pay and the lower price that producers receive generates for the government tax revenue. So that's the areas B and D. B previously was going to consumers and now it goes to the government. D was previously going to producers and now it goes to the government. And consumers are left with area A and producers are left with area F. So why do taxes create this deadweight loss? It's for a similar reason to our quota and price control discussion. When they change the prices, when taxes change the prices for both sides of the market, increasing it for consumers, decreasing it for producers, that change in price deters the marginal producers and consumers who otherwise would have engaged in exchange. So now with that lower amount of exchange, some value is not created and it's lost, right? It just never occurs. It's just lost in the market. If the tax is larger, right, you can compare tax size 1 to tax size 2 here. It's going to generate a greater deadweight loss, but also a greater area of revenue. So previously in this graph at equilibrium, we would have seen consumer surplus be area A, B, C, and then half of D, E, F. And producer surplus would have been half of D, E, F plus G, H, and I. With the small tax, right, tax revenue is D, and E, with F being deadweight loss. Consumer surplus would be A, B, and C. Producer surplus would be G, H, and I. But then when that tax grows to tax 2, now consumer surplus is just that area A, producer surplus is just that area I, B, D, and G all go to the government as revenue, and then C, E, F, and H all are lost as deadweight loss. Okay. So again, with the larger tax, the price that consumers pay is larger, and the price that the producers receive is lower. And so we see a larger decrease in quantity supplied and quantity demanded, meaning that that deadweight loss is going to be larger and more surplus is transferred to the government because of the greater wedge between the price that consumers pay and the price that producers receive. And again, consumer surplus will be smaller as well as producer surplus. So when we're talking about taxes, it's not always going to be sellers who are legally required to pay the tax. And for our economic analysis, it actually doesn't matter who is legally required to pay the tax. So when we're thinking about tax incidence, what we're thinking about is not, again, legality, but who's actually taking on the cost, who's actually bearing more of the burden of the tax. So again, it does not matter who is required to pay the tax. What's going to determine tax incidence for us is the relative elasticity of the curves. So take, for example, the set of graphs here. We have the same market. In market A, sellers have the tax applied to them. And so we see that legally applied to them. And so we see that supply curve shift up into the left. In graph B, we see that consumers have the tax applied to them, so demand shifts down into the left. What I hope you're noticing between these two graphs is the effect is the same, right? That disparity between the price that buyers pay and the price that sellers receive is the same in both graphs because the size of the tax is the same, right? And note here that tax is defined by the difference in the price that consumers pay and the price that sellers receive. That difference in price, because it's the same, elicits the same reduction in quantity traded in both graphs. And so deadweight loss is going to be the same. The revenue generated for the government is going to be the same. Consumer surplus and producer surplus are going to be the same, right? All of our outcomes of interest are the same, regardless of who legally has to pay the tax, right? What is going to change that burden is the relative elasticities of the curves. So you can see here in graph A, supply is very inelastic and demand is very elastic, whereas in graph B, demand is very inelastic and supply is very elastic. So when supply is very inelastic, what we see is less of that producer surplus is transferred to the government as revenue than when supply is more elastic. When supply is more elastic, more of that, excuse me, consumer surplus, not producer surplus. Consumer surplus is transferred to the government. So essentially, whoever is less willing to walk away from the exchange is the one who bears more of the burden. So in graph A, supply is very inelastic. So that means sellers are less willing to walk away from that exchange, whereas consumers are more willing to walk away. And so you see that consumers bear much less of that burden from the tax, much less consumer surplus is transferred to the tax than in the case of when demand is more inelastic, right? They're giving more. Producers, when their supply is inelastic, transfer much more to the government in terms of revenue than when their supply is more elastic than demand. Right? You can think about it maybe with regard to relationships. So if you've ever been in a relationship where one of you was more invested than the other, often what ends up happening is that person who is more invested ends up giving more to the relationship to make it work to the other person. And so you can think about that the same way in the market. The side of the market that's more invested, that side of the market that has a more inelastic curve is going to end up giving up more surplus in order for the exchange to happen. Right? So when consumers are less willing to walk away, they give up a larger share of their surplus than when sellers are less willing to walk away. Okay. If we go back, right, that slide summarizes that. So when demand is more elastic, consumers experience less burden, right, because they're more willing to walk away. Whereas when supply is more elastic, producers experience less of the burden, again, because they're more willing to walk away. Okay? So whoever has the more elastic curve bears the least burden from the tax. We could actually calculate the share of the tax borne by consumers and producers by looking at their relative elasticities. Okay? So notice that in our graph for the share borne by consumers, it depends primarily on producers, right? How elastic is that producer responsiveness compared to consumers? Whereas for producers, that depends on consumers, right? How much more responsive are they compared to producers? All right. There's another method besides shifting curves that we can use to model a tax. This is called the wedge method. This is my preferred method of graphing taxes. You don't have to use this method, although I do recommend trying to use it if you can. The reason I like this method is no curves are shifting, which in my experiences reduces confusion about how prices change. Okay, often when students shift a curve to show the effect of a tax, they forget that there needs to be an actual wedge between the price that consumers and producers pay, right? And then their analysis goes wrong. So with the wedge method, no curves are shifting, and you really get to see very clearly the divide that is placed between the price that buyers pay and the price that sellers receive by the tax. Okay, so if we have our tax wedge in our market for coffee, it's going to be taxed at $1. Currently, the equilibrium price is $2. We're going to fit that tax wedge into the left side of our equilibrium point to represent the $1 wedge that now exists between the price that buyers pay and the price that sellers receive. So with this $1 wedge, buyers now pay $2.65 and sellers receive $1.65, right? So you can see that $1 difference between those prices as is represented by that wedge. That divergence in price for consumers going up, for producers going down, reduces the quantity traded to 500 as quantity supplied and quantity demanded both fall the same amount, right? And we can see the relative tax burden here. So in this case, demand is much more inelastic than supply. And so sellers are taking on less of that burden than buyers, right? Buyers are taking on 65 cents of all the 500 cups of coffee sold, whereas sellers are only taking on that 35 cents of that tax over the 500 cups of coffee sold. And we can calculate the tax revenue just by multiplying the size of the tax by the number of cups of coffee sold. Right. Deadweight loss is that blue triangle. It's showing the amount of coffee that was not traded due to the tax. Again, it's the lost gains from exchange. We can find the area of that deadweight loss by using our area of a triangle formula. So 1/2 times base times height. Our base is the amount sold under the tax taken from the amount sold in equilibrium, so 700 minus 500. And our height is the size of the tax. So the difference between the price that buyers pay and the price that sellers receive. So we'll have 1/2 times 1 times 200, and that's going to get us to $100 of deadweight loss. Okay. A subsidy is just like a tax. It's essentially the opposite. So a subsidy is where the government is paying people in a market rather than people in the market paying the government. So the price of a subsidy, the subsidy is going to decrease the price that buyers pay and increase the price that sellers receive. We see government subsidies in many products. Ethanol is a big one. Research and development, tons of government subsidizing of R&D work. For consumers, education has been a big one historically, as well as public transportation. So a subsidy, like we said, is going to have the opposite effect of a tax. The supply curve, when the subsidy is applied to the supply side of our market, is going to shift down and to the right. This is going to lower the price that buyers pay for that good, while the price that sellers receive will be reflected on the original supply curve. And again, we have that wedge between the price that buyers pay and the price that sellers receive, such that now the price for sellers is going up, so quantity supplied is going up. And for consumers, the price is going down, so quantity demanded is going to increase as well. All right. So this wedge between the prices induces quantity supplied and quantity demanded to both increase. So we get more quantity traded in the market for a subsidy. Okay. Because the subsidy is making this sort of overconsumption in the market possible, we're going to see an overlapping of consumer and producer surplus. So before the subsidy, consumer surplus was areas A, B, and C. Now, after the subsidy, it's areas A, B, C, F, and H, right? Before the subsidy, producer surplus was J, F, and G. Now, with the subsidy, it's J, F, B, C, and G, right? So we get that overlap, right? Where both consumers and producers are enjoying areas F and G after the subsidy. We have some deadweight loss, even though we have more trades in this market than in equilibrium. And the reason for that is if you look at the supply curve and the demand curve for the additional units from quantity 1 to quantity 2, you'll see that for these, supply is above demand, right? And remember that supply is a marginal cost curve and demand is a marginal revenue curve, right? So what this means is for the additional units from Q sub 1 to Q sub 2, the costs of production actually exceed the benefit that consumers get from those units. So what that means is consumers actually would rather something else be made for them to consume, but because of the subsidy, that signal is blurred. And so they end up consuming more than they did previously, and sellers end up producing more than they would have otherwise, right? And that's why we have that deadweight loss. We have units of this product being made that actually costs more than consumers value them at. Last thing we need to look at is the cost to the government. So the government is again allowing this overproduction to occur. It's allowing for consumer and producer surplus to overlap. So the cost of the government is going to be the areas of overlap, so B and F, as well as C and G. And then it will also be area D, H, E, and I, right? It's covering all this additional output, as well as allowing for the lower price to consumers on units 0 through Q sub 1. And then the higher payment for producers over units from 0 to Q sub 1. So subsidies, just like all of our other interventions, distort market outcomes, and this is due to the changes in price that they elicit. So the price for producers is going to increase while the price for consumers is going to decrease, and the government subsidizes that difference. Okay. The decrease in price for consumers is going to increase quantity demanded, whereas the increase in price for producers increases quantity supplied. So we have those values remaining in equilibrium, they're remaining equal in this market, but just now at a higher level, which is what gets us the deadweight loss. Right now, the good is being traded beyond equilibrium. Units that are valued less than what it costs to make them are being produced, and so we have deadweight loss. Again, the subsidy covers the difference between the prices that consumers pay and the price that producers receive, allowing for both consumer surplus and producer surplus to increase, and they're going to overlap, right? In this case now, both are enjoying F and G, right? As well as B and C. So for our subsidy, rather than thinking about who bears the burden like we do for a tax, we think about who is getting most of the benefit from the subsidy. So that subsidy's benefit, the distribution of it, depends on the relative elasticities of our demand and supply curves. So whoever it bears the burden of the tax is going to get the benefit of the subsidy. So in our graph here, you can see demand is relatively elastic, where supply is relatively inelastic. So sellers are less willing to walk away from this exchange. And so they are going to bear more of the burden of the tax, but that also means that they get more of the benefit of the subsidy. Okay. Just like with taxes, we can use the wedge method because who gets the benefit from the subsidy does not depend on who it's legally given to. And so we want to be able to see that very clearly. So if we have, again, our market for coffee with our subsidy wedge of $1, we're going to fit that wedge to the right of equilibrium. And that's going to show us the wedge that is created between the price that buyers pay and the price that sellers receive, as well as show us how the quantity traded reacts. So the price that sellers receive, as we can see by where the wedge hits that supply curve, goes up, and the price that consumers pay goes down, as we can see based on where that wedge hits that demand curve. So consumers pay $1.40 for a cup of coffee rather than $2 as they did in equilibrium, and sellers receive $2.40 rather than just $2. So that is increasing the quantity traded to 900 from 700. And here we can see the distribution of surplus. So consumer surplus is this purple triangle, right? That entire area below the demand curve and above the price that buyers pay. Consumers get this blue triangle, which is below the price that they receive and above their supply curve. Deadweight loss is the overproduction of the additional 200 cups. And then the cost to the government is that pink rectangle, right? It's the size of the subsidy. So $1 times the number of cups of coffee sold. So with that, those are all our interventions. The next video will go over some practice problems that you're likely to see on your assignment as well as the exam. And then we'll be turning to chapter 9, where we'll look at the monopoly and monopolistic competition models of our market.